Okay, so anyone who's been following AI knows there's been a ton of buzz around large language models, LLMs.
Yeah, for sure.
But what's really got me excited is, seeing them move beyond those general applications and actually tackling like really specialized fields like cybersecurity and healthcare.
Yeah, yeah.
And we've got a great white paper here that really digs into that and specifically how, fine-tuning LLMs for, these specific areas isn't just some like cool trend. It's a real strategy that's already like producing some pretty significant results and opening up all sorts of new possibilities for how we get things done.
Yeah, it's pretty amazing to see. And for this audience, you guys are all really tech savvy. It's less about the broad capabilities of these models and more about how they can, be focused to solve like really complex problems in these specific areas.
Right.
So this white paper, it really gives you a look under the hood at how that's happening. And I think our goal in this deep dive is to kind of pull out the really crucial insights from it. The challenges, the breakthroughs, the practical progress in applying these models specifically to cybersecurity with SecLM and to medicine with MedLM.
Okay, so let's jump right in and start with cybersecurity.
Yeah.
Forget that whole Hollywood image of like the lone wolf hacker in a dark room.
Yeah.
This paper makes it super clear that the day-to-day for security professionals, whether they're developers, system administrators, analysts, it's just this constant fight against a flood of new threats.
Yeah.
It really is like pushing a boulder uphill. And so much of their time is just eaten up by these like really routine manual tasks, just trying to stay ahead of the curve.
And what the paper really highlights really well is, it kind of pinpoints the three major pressures that are happening in cybersecurity right now.
Right.
One is just this constant emergence of new and more sophisticated ways of attacking.
Yeah.
The second is the amount of just like grunt work that the operational toil that security teams have to deal with.
Yeah.
And then finally, there's this persistent shortage of skilled professionals in the field.
Yeah. So not only are they fighting an adversary that's always, changing tactics, but they're also spending so much valuable time on these tasks that could be automated. And on top of all that, there just aren't enough people with the skills to do this work.
Right. Exactly.
Which is where the emergence of Gen AI and specifically large language models is offering a really interesting solution.
Yeah.
It's not about replacing these security experts, but giving them, almost like an AI assistant that can take care of a lot of that tedious work.
Yeah.
Freeing them up to focus on the really complex strategic stuff.
It's about empowering them to do more, to do the things that they're really good at and to be more effective.
Right. And the paper gives some really concrete examples of how this could work. For security analysts, LLMs could translate, natural language into the syntax of complex query languages. So they don't have to spend, hours crafting those queries manually.
Yeah.
They could help automate the investigation and categorization of alerts and even generate personalized remediation plans based on the specifics of an incident.
Exactly. And for threat researchers and system administrators, imagine the potential of AI to automatically, reverse engineer and understand that malicious software, the stuff that's intentionally obfuscated and hard to unpack.
Right. And this is just the tip of the iceberg. The paper talks about CISO teams using LLMs to generate really clear summaries of the threat landscape,
Yeah.
Specific to their organization.
Yeah.
IT administrators and security teams could get insights into potential attack pathways and get recommendations on the most effective preventative measures. Even developers could benefit from using LLMs to identify critical areas for security testing and even to generate, secure code snippets.
Yeah. It's amazing to think about how much this could impact every level of security.
Absolutely.
And the paper really emphasizes that, this isn't about finding like one solution. It's about a layered approach. They talk about, at the top, you've got your existing security tool providing the data and the context. Then in the middle, you have the specialized model API, and that's where SecLM comes in.
Right.
And then underpinning it all, you've got that authoritative security intelligence and human expertise.
Okay.
What's so interesting is that the LLMs can process all this diverse security data that's, often really fragmented.
Right, which is a huge problem for so many security operations.
Exactly.
And the SecLM, this API that's being developed, it's envisioned as that central resource for security questions.
Yeah, that one-stop shop.
The idea is you could ask questions in plain language, point it to your internal data sources, and it gives you an answer that pulls from all that information.
Exactly.
So no more trying to stitch together complex search queries or manually integrating data from a million different
Yeah,
systems.
it's the dream, right?
Right. But to make that kind of seamless experience a reality, Second Line has to meet some pretty high standards.
Oh, yeah, definitely.
The threat landscape changes so rapidly. So they have to address, keeping the model up to date.
Timeliness is key. Yeah.
It also has to be able to analyze, sensitive user-specific data
Right.
without any risk of that data being,
Yeah,
exposed.
within their environment.
Right. It needs deep security knowledge,
Yeah.
understanding the concepts of the terminology.
Yeah. Be able to speak the language.
Right. And finally, it has to be capable of multi-step reasoning.
Yeah. Combining different data sources and models to really get to the bottom of those problems.
Okay, so how do they do that? The paper explains why those general purpose LLMs often fall short when it comes to these really specialized security needs.
Yeah.
For one, there's not a lot of publicly available high-quality security data
Yeah.
to train on the details of real-world incidents. Are usually confidential for obvious reasons.
Right.
And the limited data that is out there often focuses on, really popular products or general concepts. It's missing that real-world context.
Exactly. The nitty-gritty details.
Right. And the sheer breadth and depth of security knowledge is another obstacle.
Yeah.
You're dealing with everything from low-level system architecture to high-level security policy and threat intelligence.
It's a lot for a model to grasp. Yeah.
Right. A specialized security LLM needs to be fluent in all of that, and be able to connect those technical details with the bigger picture.
Right. And then you've also got those really sensitive use cases like analyzing malware or phishing campaigns, which general purpose models often avoid because, there's always that risk of misuse.
Right. Right. So how do they go about creating these specialized SecLMs?
So they start with a very targeted training approach.
Okay.
They begin with a strong general purpose foundation model.
Okay.
And the paper highlights the advantage of, making sure it has multilingual capabilities from the get-go,
Okay.
because you need to be able to analyze threat intelligence that's coming from all over the world.
Yeah, that makes sense.
Then they do further pre-training, but this time it's all about cybersecurity-specific content. Think blogs, threat reports, detection rules, even like full IT security textbooks.
So this is where it really starts to learn the language of cybersecurity.
Exactly. It's building up that foundational understanding.
Okay.
Then they move on to supervised fine-tuning. And this is where they train the model on tasks that mirror what security experts actually do in the real world.
Okay.
So that's
Okay.
things like, analyzing potentially malicious scripts, explaining command line instructions, interpreting those security event logs, summarizing complex threat reports, and even generating queries for security management platforms.
Wow, so they're really putting it through the paces.
Yeah, and it's important to note that all of this is done with a focus on privacy. So user-specific data is kept separate and only used within those very specific fine-tuning tasks.
Okay, that's good to hear.
Yeah.
So how do they actually evaluate the performance of these specialized models?
Well, it's a multifaceted approach.
Okay.
For tasks where there's a clear right or wrong answer, like classifying malware. They use those standard classification metrics.
Uh-huh.
But for more open-ended tasks, they compare the model's output to expert-provided answers using different metrics that measure how similar the generated text is.
Okay.
Metrics like Rouge and BERT score, things like that.
Right.
They even use larger LLMs to do like automated side-by-side comparisons and rank different responses.
Wow.
But at the end of the day, because this is also technical and accuracy is so important, human evaluators play a really crucial role.
Yeah, they're the ones who can really judge, how well the models do.
Exactly. They review the outputs and provide that essential qualitative feedback.
Okay, so even after all this specialized training, the models still need some help sometimes.
Right. It does.
And the paper talks about techniques like in-context learning, retrieval augmented generation, RAG,
Yeah.
and parameter-efficient tuning, P.
All important tools.
So what do those actually do?
So imagine you have a brand new security platform that wasn't part of the training data.
Okay.
With in-context learning, you can give the model a few examples of how to interact with that platform, and it can adapt really quickly.
Yeah.
And if a user wants to, incorporate their organization's unique network configurations or align the model's analysis with their internal expertise, PET lets you do that lightweight customization without having to retrain the whole model.
That's really useful.
It is, and
Y- y-
ROG is really important for keeping the model up to date on the latest threat intelligence.
Right.
It lets the model pull in information from external sources in real time.
So it's always got the most current information.
Exactly.
So all of this leads to what the paper calls a flexible planning and reasoning framework.
Uh-huh.
And they illustrate this with a great example using the APT41 threat group.
Yeah.
Let's say a security analyst asks a high-level question about APT41's common attack methods.
Okay.
The SICK LM API has to orchestrate a whole series of steps to answer that.
It's not a simple lookup.
Right. It has to retrieve information about APT41, extract those key TTPs, and IOCs translate that into a query that can run against the user's SIEM system.
Exactly. And that sequence of actions can be predefined for common scenarios or generated in real time based on the user's question and the available resources.
Okay, so it's kind of like a dynamic workflow.
Exactly.
So the API gets the latest intel on APT41, identifies those crucial details, uses a pet-tuned model to translate them into the SIEM's language, retrieves the relevant security events from the SIEM, and then compiles all of that into a clear answer for the analyst.
Right.
The paper estimates that this kind of automation could save analysts hours of work.
It's a huge potential time saver.
That's amazing. And they talk about other applications too, like interacting with external security tools, using RAG for threat intelligence, even employing specialized models for very specific analytical tasks.
And even a form of long-term memory so it can remember user preferences and context.
Oh, wow.
Yeah, and they actually have a figure in the paper that shows SecLM analyzing a PowerShell script side by side with general-purpose LLMs, and it really highlights the advantages of that security-focused approach.
So what's the big picture here? What's the ultimate goal for SecLM?
The goal is for it to become this central platform that can truly transform how cybersecurity is practiced.
Okay.
You know, significantly reducing that daily burden on security professionals at every level.
That would be a game changer for sure.
It would.
Okay, so let's shift gears a bit and talk about healthcare and the development of MedLM.
All right.
So the paper really highlights the potential for Gen AI to transform medical question answering.
Yeah, it's a big deal.
Anyone in the medical field knows that accurately answering medical questions with AI has always been a huge challenge.
Right.
Because of just the sheer volume of medical knowledge that's out there and the need for nuanced reasoning.
And it's constantly evolving, too.
Right, exactly. But what's really exciting is that these large language models are now able to understand and apply these complex medical concepts in a way that we haven't seen before.
Yeah, it's a big step forward.
And this is happening alongside, the increasing availability of medical data and the advancements in medical NLP.
Right, it's all coming together.
It's creating this perfect storm for innovation.
Yeah.
And this led to the development of MedPolem, which is an LLM that's adapted from Google's Polem family.
Uh-huh.
And it's specifically focused on improving health outcomes.
That's the goal.
Okay, so what are some of the ways that Gen AI could be used in healthcare?
Well, imagine patients being able to ask questions about their own medical history and get personalized guidance,
Okay,
like tailored advice on post-op recovery.
that would be amazing.
Or picture an AI system that can triage patient messages to the right clinicians, understanding the urgency and categorizing the issue based on the patient's entire medical record.
Wow.
It could even revolutionize patient intake, moving beyond those standardized questionnaires to a more dynamic and comprehensive process.
So it's really about personalizing the patient experience.
Exactly.
And it could even provide real-time feedback during consultations, helping both the patient and the clinician understand, the key points.
Yeah, and for clinicians facing, those really unusual or unfamiliar scenarios, imagine having like an AI consultant with access to this vast, up-to-date body of medical knowledge.
That would be incredible.
It would.
But of course, with all of this potential, there's also the need for caution.
Absolutely.
The paper emphasizes the importance of responsible innovation, especially in medicine, where patient safety is paramount.
Yeah.
And they highlight the need for rigorous validation
Yeah.
through retrospective analysis and prospective studies,
Yeah.
before any of this technology can be used in clinical practice.
We have to be absolutely sure that it's safe and effective.
Right. And the paper also talks about the shift in the scientific approach.
Yeah.
Many current AI systems in medicine generate those very structured outputs.
Yeah.
Yes, no answers, numerical results.
Right.
And while those are useful, they lack the flexibility needed for real-world interactions.
Exactly.
And the vision here is to create more human-centered AI.
Yeah, systems that can interact with people in a more natural way, taking into account the context of the situation.
So it's not just about data and algorithms. It's about language empathy,
Yeah.
understanding the human element.
Exactly. And MedPolem is presented as that first step towards this vision, starting with the fundamental task of question answering.
Okay.
Which, might seem simple, but it's actually a powerful way to evaluate a model's ability to reason across a wide range of medical knowledge.
Right.
The big picture here is the emergence of these foundational models like LLMs.
Okay.
And they offer us a chance to really rethink how we develop and apply AI in medicine with the potential for huge improvements in performance, safety, accessibility, and fairness.
And how has MedPolem progressed so far?
Well, we've seen some really rapid progress from the initial MedPolem to the more advanced MedPolem 2.
Okay.
The first version was a huge milestone. It was the first AI to surpass the passing score on those USMLE-style medical licensing exams.
Wow.
Then MedPolem 2 went even further, achieving expert-level performance on those same exams.
That's amazing.
It also showed significant improvements in the quality and depth of its long-form answers as evaluated by physicians.
So how do you even measure something like an AI's medical knowledge?
It's tough.
Yeah.
But the paper outlines a really comprehensive evaluation strategy.
Okay.
It combines quantitative metrics with qualitative assessments.
Okay.
So they use those USMLE-style questions as a benchmark because answering them correctly requires, deep understanding of medical concepts interpreting patient information, clinical reasoning.
It's not just about memorizing facts.
Exactly.
And the jump in performance from MedPolem to MedPolem 2 is remarkable.
It went from a 67% passing score to 86.5%.
Wow.
Moving from basic competency to actual expert-level knowledge.
But it's not just about those multiple choice questions, right?
No, the evaluation goes way beyond that.
Okay.
They also do qualitative assessments looking at things like the factual correctness of the information, the appropriate use of medical knowledge, the helpfulness of the response potential biases, and the potential for harm.
Right. So they're really looking at the big picture.
Exactly. They want to make sure that the AI is providing safe and useful information.
And the paper goes into a lot of detail about the criteria used by those expert clinicians.
Yeah. They cover everything from whether the answer aligns with scientific consensus to whether it could be harmful.
Okay.
They look for correct comprehension of the question, accurate recall of information, sound clinical reasoning, all of those things.
So they're really scrutinizing the model's responses.
They are, and the process for these human evaluations is really rigorous too.
Okay. How does it work?
So both MedPolem and teams of physicians answer the same medical questions independently.
Okay.
Then the responses are given to a separate group of expert raters who compare them side by side.
Okay.
But the focus is on the substance of the answers, not just the style or phrasing.
So they're really trying to get at the core of the model's understanding.
Exactly. And while the models are showing really impressive performance compared to those physicians, there are still areas where they need to improve.
So it's not perfect yet.
No, but it's getting there.
And the paper makes an important point that, scoring well on these data sets doesn't automatically mean the technology will work in the real world.
Right.
They talk about their own experience with AI for diabetic retinopathy screening and how it highlighted the need for careful validation in real healthcare settings.
We can't just assume that it's going to translate perfectly.
Right. And they emphasize the need for a progression of studies, starting with retrospective analysis, then prospective observational studies, and finally prospective interventional studies.
Where the AI's recommendations actually impact patient care.
Right. So it's a step-by-step process to make sure that the technology is safe and effective.
Exactly.
And this leads us to the distinction between models designed for specific tasks versus those that are designed for a broader domain like MedPolem.
Yeah.
MedPolem's success shows the value of that domain specialization.
It does. And MedPolem 2 showed a marked improvement in its reasoning abilities within the medical domain.
That's great.
Yeah.
But even so, you can't just assume that it will excel in every medical task.
Right. Each application needs to be carefully validated and adapted.
And they also mention the multimodal nature of medicine.
Yeah.
The importance of integrating information from images, EHRs, sensor data, genomics, all of that.
It's all connected.
Right. And they're doing some early research into creating multimodal versions of MedLM that can handle all of that.
Yeah. It's exciting to think about the possibilities.
And it's also worth noting that these models have applications beyond patient care.
Right. They can be used for things like scientific discovery.
Like helping researchers identify genes associated with specific traits.
Exactly.
And looking to the future, the introduction of MedLM as a suite of commercially available models built on MedPolem 2 is going to be huge.
Yeah, it's going to allow healthcare organizations to build their own Gen AI solutions.
That's amazing. And finally, the paper gives us some insight into how MedPolM2 is trained.
Yeah, so it builds upon the base LLM Polym too, and it's fine-tuned using a ton of medical question answering data.
Okay.
They use a bunch of different prompting techniques for multiple choice
Like
questions,
what?
like few-shot prompting, chain of thought prompting, which encourages the model to show its reasoning steps,
Oh,
and self-consistency, which helps improve accuracy.
so it's not just guessing, it's actually thinking through the problem.
Exactly.
Hmm.
And they also use something called ensemble refinement.
What's that?
It's a technique where the model actually takes into account its own generated explanations and uses them to refine its final answer.
So it's learning from itself.
In a way, yeah.
Wow, that's fascinating.
So to wrap up our deep dive, we've seen how LLMs are showing incredible potential in these complex, domain-specific challenges, particularly in cybersecurity and healthcare.
Yeah, we've covered a lot of ground.
We have.
In cybersecurity, SecLM has the potential to be a real game changer, automating those time-consuming tasks, addressing the talent shortage, and ultimately revolutionizing the way security is practiced.
It's about combining the power of AI with the expertise of human professionals.
Right, and in healthcare, MedLM is tackling the growing complexity of medical data, unlocking valuable knowledge, and ultimately aiming to improve the effectiveness and efficiency of healthcare delivery.
And it's done this while demonstrating expert-level performance on those challenging medical question-answering tasks.
Which is incredibly impressive.
It is, but it's important to remember that collaboration with clinicians and careful evaluation in real-world settings are crucial.
Absolutely.
The development of these vertical-specific foundation models like MedLM really points to a future where AI is deeply integrated into healthcare.
It's an exciting time to be following this technology.
It is.
This white paper really shows the transformative potential that lies at the intersection of LLM's domain expertise, human insight, and careful implementation.
It's about using these powerful AI tools to achieve real breakthroughs and ultimately improve people's lives.
And that brings us to a final thought for you. We've talked about the rapid advancements in both SecLM and MedLM and how both security and accuracy are so crucial in these fields.
Right.
So what do you think about the potential synergies or maybe even conflicts that might emerge as these technologies become more integrated into our digital infrastructure and our health systems?
Yeah, it's a good question.
How might the lessons learned in securing sensitive data in one domain inform the other?
It's a complex landscape, and we'd love to hear your thoughts on this.
Yeah, it's definitely something to ponder.
It's a really fascinating and rapidly evolving field with huge potential for both progress and challenges. We encourage you to dig into this white paper, explore the concepts we've discussed today, and really think about the implications of these advancements for your own work and interests.
This is just the beginning.
It is the journey of applying these powerful tools to solve real-world problems is just getting started, and your engagement and your critical thinking are going to be essential in shaping its future.
So keep those questions coming.
Absolutely. Let's keep the conversation going.
Thanks for joining us for this deep dive.
It's been a pleasure.
We'll see you next time.
See you then.